Modern Astronomy, Moving into the Future. After Newton, astronomy had become a true science. Observing the natural world, applying the rules of mathematics, and testing hypotheses became the method by which models in space science were now developed. William Herschel, born in 1738. A quote from William Herschel reads, "I have looked further into space than ever human being did before me. I have observed stars of which the light, it can be proved, must take 2 million years to reach the earth." William Herschel was born just 11 years after the death of Newton in Hanover, Germany in 1757. He traveled to England, where he remained for the rest of his life. Herschel was a music teacher who loved to observe the heavens. Since Galileo's time, telescopes had become more and more common. By Herschel's time, telescopes had come into common use. Anyone who had enough money could become an observational astronomer. Herschel spent as much time as he could observing the universe through his telescope. It was soon apparent that he required a better telescope, one that could show him the finest details of the moon and planets. The only problem was that his income from teaching music was too small for him to afford one of the best telescopes. Herschel decided that the solution to his problem was to build his own telescope. After months of careful work, Herschel had completed a large curved mirror that was the main component of a reflecting telescope. His skill at producing large mirrors became so developed that he soon produced the best telescopes in Britain. On March 13th, Herschel discovered an object in the sky that looked like a small green disk. He observed that the disk was moving slowly across the sky. Herschel concluded the object must be a comet and reported his conclusion to the Royal Society in London. It was determined later that it was not a comet, but rather a new planet. The discovery of a new planet beyond Saturn was a surprise to everyone at the time. Herschel became such a celebrity overnight that he was awarded a grant by the British King George III. Herschel was now able to develop himself full time to the study of astronomy. Herschel named the planet Georgium Sidus in honor of King George, but everyone else called it Uranus. Herschel wanted to study the motion of stars and the composition of the Milky Way. As he began counting stars, Herschel must have realized the enormous task he had set for himself. He devised a new way of counting called stargazing, in which he would select off small parts of the sky and count the stars in that section. In this way, he discovered millions of stars with his telescope, knowing that a better telescope would probably reveal millions more. As he counted the stars, Herschel realized they clustered in such a way that he declared they formed powder puffs in space. Not these kind of powder puffs, though. Space scientists discovered later that Herschel was absolutely correct. Today, some of the powder puffs are called galaxies. Our powder puff is called the Milky Way. Our sun is located near the edge of the Milky Way. As he looked deeper into space, Herschel observed clouds of light, which he interpreted as more groups of stars. Herschel called these clouds in the sky island universes. These clouds had been observed by other astronomers and were called nebulae. That's the plural for nebula, which, not surprisingly, is Latin for cloud. Herschel stated these clouds could be other galaxies beyond our own Milky Way. Later, more powerful telescopes had shown that Herschel's inspired guess was correct. The work of Herschel and other scientists paved the way for modern space science. Scientists from Galileo onward have been able to use the telescope to look farther into the heavens as it had been as it has been refined and modified over the years. The telescope has also changed the way we see. In addition to using visible light, telescopes can use different parts of the light spectrum to analyze objects in space. The refracting telescope. The earliest telescopes were refractor telescopes. Galileo's telescope was a primitive refractor, but it allowed him to see celestial objects in greater detail than was possible before Galileo manufactured his own telescope in 1608. His telescope was capable of taking in 30 times the light compared to his eye alone. Astronomers experienced a problem with the early telescopes. A refractor telescope bends light as it enters the front objective lens. However, different colors of light refract or bend different amounts. As a result, simple refractor telescopes produced a hazy ring of color around the image. Eventually, a British astronomer found that by placing a carefully fitted lens with the object or on the front lens, the objective or the front lens, two lenses overcame the problem. Astronomers wanted to look farther into space and see objects more clearly. Larger lenses in telescopes meant greater light gathering capacity, allowing a close look at planets, moons, and stars. Producing a larger lens was a difficult task, as the light had to pass through the lens. There could be no there could not be any imperfections in the pouring of the molten glass or the grinding of the lens to form the correct shape. As a result, the practical limit to the size of an objective lens in a refractor telescope was 4 inches for many years. At the end of the 19th century, giant lenses were being built. The two largest to this day are 92 centimeters and 102 centimeters, uh, built in the United States. There are two restrictions to the size of the lens in refractory telescopes, however. Larger lenses cannot be built without imperfections in the glass. The other thing is the lens becomes so heavy that it bends under its own weight, producing a distorted image. The 102 centimeter telescope at Yerkes Observatory is extremely powerful, allowing a light gathering capacity of 40,000 times that which can be seen with the naked eye. The reflecting telescope. Reflecting telescopes were built in the 1600s. The refractor telescopes had problems with a colored haze around the image. Astronomers looked for a solution in other telescope designs. One design that became popular is called the reflecting telescope. The reflecting telescope was first constructed by Newton in 1668. A reflecting telescope has the advantage of using a concave mirror to gather light instead of an objective lens. Mirrors are much easier to build than lenses as light reflects off the mirror instead of traveling through. Mirrors need to have a shiny surface that is easier to build. Light travels into the telescope, reflects off the concave reflective mirror, and hits the flat mirror that reflects the light again through an eyepiece lens into the eye, as you can see in the picture here. Large reflecting telescopes were being built as early as 1845, when Lord Rosse created a 184 centimeter mirror. One of the most famous reflecting telescopes is the 510 centimeter reflecting telescope located at Mount Palomar in California. The one restriction to building super large reflecting telescopes is the difficulties encountered when when the glass making up the mirror is being cooled. The cooling process must be regulated carefully or the glass will crack. In order that the large reflecting telescope can take advantage of their huge light gathering capacity without the image being distorted by atmospheric conditions, they are constructed on mountains where the atmosphere is as clear as possible and there is no glare from city lights. The radio telescope. You know that as you look at a star, you are looking at visible light that began its journey some time before you saw it. The light you see is only a small part of the whole spectrum of radiation produced by the star. The full spectrum of radiation is called the electromagnetic spectrum. The electromagnetic spectrum contains radio waves, infrared light, visible light, ultraviolet light, X rays, and gamma rays. All parts of the electromagnetic spectrum travel through space at the speed of light, which is close to 300 million meters per second. Each, sex, each section of the spectrum can be used to tell space scientists something about objects in space. You have used a radio to listen to your favorite music in the car before. Scientists can do the same by using radio telescopes. The music the music listened to by scientists, however, is slightly different. A radio telescope looks like those old giant satellite dish that people used to use for satellite TV. The giant dish reflects the radio waves to a collector located in front of the dish. The largest single dish radio telescope in the world is this one right here. Radio telescopes have been used to make some remarkable discoveries in space science. The first hint of radio wave activity in space came when a research engineer was doing some research in an attempt to eliminate static in in the radio transmission. Shown here is the apparatus he used. In the process of picking up static, it also picked up a steady hiss. The engineer, Karl Jansky, realized he was receiving a radio signal from the Milky Way. Using Jansky's findings, an American named Grote Ruber built a small radio telescope. He used it to find signals like those Jansky found from several different sources in different parts of the universe. Radio telescopes have been responsible for some exciting discoveries that have answered some questions. But they have also created some puzzling questions. Radio telescopes have found some very distant objects that have produced unusually strong radio signals. How could some object in space so far away produce a strong signal? Radio telescopes were responsible for the discovery of neutron stars, which produce a varying signal made of pulses that are 1.3 seconds apart. These signals, called pulsars, are initially thought to have come from some alien civilization and caused great excitement in the scientific world for a time. Radio telescopes were used to detect quasars, offering science its greatest mystery today. Quasars are celestial objects that look like stars, but they give off much more energy than a star. Quasars could be the product of colliding galaxies. Other telescopes. Infrared telescopes use the infrared portion of the electromagnetic spectrum. It is possible to look through and see anything in these telescopes since our eyes are not sensitive to the wavelength on the electromagnetic spectrum. Some types of photographic film are sensitive to wavelength, and pictures can be taken which show images of objects in space detected by the telescope. Other telescopes detect high energy radiation from stars. High energy radiation refers to the X ray and gamma ray portions of the electromagnetic spectrum. These telescopes work best in space as the Earth's atmosphere has a scattering effect on infrared and absorbs the high energy radiation. Satellites loaded with telescopes that were able to detect infrared and high energy radiation have been sent into space, yielding spectacular results that promise to keep scientists occupied for years with their yield of experimental data. The Hubble Space Telescope, which is the long-term orbit around Earth, is yielding images having incredible clarity. This picture shows you how big it is. See, it's about the size of a school bus. William Herschel. So, in summary, William Herschel ushered modern space science in as he made and used bigger and bigger telescopes with optical clarity that challenged the best telescopes in the world at the time. Herschel discovered a planet, the first with a telescope, and turned his attention to space beyond our galaxy. Deep space was a mystery being explored as Herschel began seeing new shapes, which he called powder puffs, but which became known as galaxies. Herschel observed nebulae, the birthplace of stars. Herschel also gave us a new appreciation for the vastness of space as he began to count stars and record how many there actually were, even in just our galaxy. Now I want you to go to the Google Classroom and complete the Modern Astronomy Practice review. Don't hand it in when you're done. We're going to go over it together. It will be important for your preparation for the assignment.